Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called 3-9 and it's by 1-4. Interesting? And here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and box. We'll get a box here. This is a box. The sum of all digits in any cage is either 3, 9, 33, or 39. Two of the sums are given in the top left of the cage, and digits cannot repeat in a cage. So we have this cage must add up to 39, and this cage must add up to 3. But every other cage has to add up to 3, 9, 33, or 39. So this could add up to, well, okay. That's sort of solving already. So, this cage could add up to 3 or 9. So therefore it would be, actually, let's use this cage. This cage could add up to 3 or 9. And therefore it could add up to 3, which would be 1 and 2, or it could add up to 9, which could be like, for example, 1 and 8, or 2 and 7, or etc., etc. And remember, digits cannot repeat in cages in this format. Also, we have thermometer, where digits on the thermometer must strictly increase as they move away from the bulb. So that's all just saying that this digit has to be greater than that digit. That's all it's saying. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so from many years of doing killer Sudokus, if you have 2 digits adding up to 3, it has to be specifically 1 and 2. So many normal Sudoku rules. If you have 6 digits adding up to 39, that means it has to be 4 through 9, because you have 3 digits, which are not in the 1 through 9 set, and the minimum you could have of those 3 digits adds up to 6, which is exactly what the digits outside of this cage have to add up to. Therefore, this must be that set. So this must be 4 through 9. This cannot be 1 and 2. Okay, we know each of the single cell boxes have to add up to 3 or 9. So this is 3 or 9, this is 3 or 9. Interestingly enough, so all the 2 cell digits must also add up to 3 or 9. And all the 3 cell digits also have to add up to 3 or 9, because none of them can add up to 33, right? The only cages that can add up to 33 or more are specifically 5 or higher. So this could be 33. Actually, this one has to be 33 because it cannot add up to 39 with only 5 digits. As we showed, the minimum for getting 39 is 6 digits. So, and it can add up to 5. It can add up to 9 with just 5 unique digits because the minimum there is 15. So this is always adding up to 33. Just like any 8 cell cage has to add up to 39. So therefore, this is 39, which forces this to be a 6 to add up to 45. These cannot have a 6, and this can't be 6. So one of these 2 is a 6 here. Because, again, none of these can contain a 6 because this is 8 digits adding up to 39, because 8 digits can never add up to 33, because that means one digit has to be size 12, which is not allowed. So again, this is 6, this is 6, one of these is a 6. So since one of these is a 6, that means there has to be a 3 with it. Because 6 cannot add up to 3, obviously. 6 and another digit can never add up to 3, but 6 and 3 can add up to 9. So 3 has to be one of these 4 digits. We're not sure which. This has to be 5 digits adding up to 33. and you cannot have a 6. So the minimum would be 5, 6, 7, 8, 9. But if you remove the 6, the next highest digit you can have is 4, 5, 7, 8, 9, which exactly adds up to 33. So this has to be specifically 4, 5, 7, 8, 9. That's 24 plus 9, which is 33. Therefore, the remaining digits are 1, 2, and 3 in the column. So this can't be 1 or 2 because of the 1, 2 pair in the row. So this must be 3, which makes these 1 or 2. These can no longer be 3. Therefore, this must be a 3, and this must be 6 to match it, to add up to 9. This also adds up to 9, but it cannot be 1, 8, or 2, 7, or 3, 6, because we already have a 1, 2 pair in the box, and we have a 3 and a 6 in the box. And it can't add up to 3, obviously, because 1 and 2 are already taken. So this has to be specifically 4 and 5, which makes these remaining 7, 8, and 9. These 6 digits can no longer add up to 39, because if that were the case, these would have to be 1, 2, and 3. Therefore, they must add up to 33. And they cannot contain 7, 8, and 9. So, therefore, it cannot be 4, 5, 7, 8, and 9. If you had 8 and 9 and you had 5, you have to have a 6 here because there is no 6 currently in the row. So you have a 6, so 33 minus 6 is 27, right? 33 minus 6 is 27, so you have 5 digits. You have to have 1 out of 1 or 2. And you have to have 1 out of 7, 8, or 9. So you have a 3 and a 6 here. One of these is 1 or 2. And the other one cannot be, the 1 or 2 cannot be here. So the 1 or 2 cannot be here because of the 1, 2 pair in the box. One of the 1 or 2s has to be here because there's only 1 or 2 here. But where is the remaining 1 or 2 in box 9? Can't be here because then that would eliminate all possibilities for that cell. Can't be here because of the 1, 2 pair. It has to be here. So this is 1 or 2. Therefore, this doesn't add up to 3. It must add up to 9. So this is 7 or 8 here. These can't be 6. 1 of 7 or 8 is here. These cannot contain a 6 either. And the 6 can't be here. So one of these must be a 6 here. And anytime you have 3 digits adding up to a digit of 3, 9, or 33, or 39, can't be 33 or 39 because 3 digits add up to at most 24, and can't be 3 because it adds up to a minimum of 6, so it must be specifically 9. So this is either 6 with 1 or 2 here. It could be 3 with 1 or 5, but this can't be 5, so this would be 1 and this would be 5. Or it could be 3 with 2 and 4. And the 3 would have to be here. So this cannot be... So this would have to be 4, if that's the case. But if this were 6, again, any 2-cell cage can only add up to 9 out of 3, 9, 33, and 39, unless it's a 1 or 2 pair. And this can't be a 1 or 2 pair because one of these has to be 1 or 2. And if this were a 6 here, anyways, it would add up to 9. So therefore, this would be 3, but that's not allowed because of that. So this cannot be a 6. Therefore, this is a 6, which forces this to be a 1, 2 pair. Therefore, these cannot be a 1, 2 pair because this specifically cannot be 1, 2. So this has to add up to 9. So it's either 1 and 8, 2 and 7. It cannot be 3 and 6 because the 6 is not on either side, or it's 4, 5 here. Well, none of these can be 7 or 8 because of the 7, 8 triplet, 7, 8, 9 triplet in the column. Therefore, this can't be 7 or 8. This can't be 1 or 2. This has to be 4 and 5 adding up together. So this can't be 4 or 5 here because of the 4, 5 pair there. This can't be 4 or 5. And it can't be 1, 2, 3, or 6. Can't be 4 or 5 because of the 4, 5 pair in the column. Can't be 1, 2, 3, 6 because of the 1, 2 pair in the box and the 3 and 6 already there. So this has to be 7, 8, or 9. And again, 6 cannot be any of these cells here because we have 8 digits adding up to, it has to be 39. It cannot be 33, 9, or 3. Therefore, where is the 6 in row 4? It has to be here. Because it can't be any of these because, again, this doesn't add up to, this only adds up to 39, which requires a 6 being left out. So 6 cannot be here, here, or here in this cage. Well, now we have a 4, 5, 7, 8, 9 quintuplet in this cage, which eliminates 4, 5, 7, 8, 9 in the rest of the cage. This can't be 4, 5, 7, 8, 9, so this must be a 6. This can't be 3, so this is 9. Oh, that's interesting. This is 3 digits adding up to, it only can be 9, right? Because it can't be 3, can't be, three unique digits can never add up to 3, 33, or 39. So this is 9. And 1 and 2 cannot be here. Well, we know we need a 1 or 2. We also know we need a 3 or 1 out of 1. Because any 3 cells that add up to 9, you always have 2 digits from 1, 2, and 3. Well, you can never have 2 digits in this cage adding up to 1, 2, or 3 because these 2 specifically can't be 1 or 2. So this has to be a 1 or 2, and the 3 has to be one of these 2 cells, and it can't be here, so it must be here. So this is 3, and this has to be specifically 4, 5 to match with the 1, 3 or the 2, 3. So this is 4, 5. What else do we have? 6 has to be one of these 2 cells, but it cannot be this one because one of these 2 must be 6. Therefore, this is a 6 here. 6 is one of the remaining cells here. And this 3-cell cage has to be adding up to 9. So it's either 1, 2, 6. So this would be 1, 2, and this would be 6. It could be 1, 3, 5, or 2, 3, 4. So the 6 is... Where is the 6 in row 2? Cannot be here, cannot be here, cannot be here, and it can't be any of these because, again, this adds up to 39, which excludes a 6. So one of these has to be a 6, which means the other one has to be a 3. Well, this can't be 3, therefore this can't be 6. So this must be the 6, and this must be 3, which makes that a 9. Therefore, this can no longer be 3. This can't be 6. The only 3 digits adding up to 9 now, without a 3, are 1, 2, and 6. So this is 6, and these are 1 and 2. Okay. 1 and 2 is one of these. These can't be 9. Therefore, for this cage, 9 has to be 1. Cannot be here. It has to be one of these 2. So one of these 2 is 9. This can't be 9, so one of these 2 is a 9. The remaining digits here are 4, 5, 7, and 8. And this cannot be 8 because 8 would be greater than all these digits. And this cannot be 4 because 4 would be less than all these digits here of the remaining digits. Now we have a 4, 5, 7, 8, 9 quintuplet in column 9, which eliminates 4, 5, 7, 8, 9 in the rest of the column. This is 1 or 2. This cannot be 1 or 2 because of the 1, 2 pair in the row. So this has to be 3, which makes this a 1 or 2. So the rest of this row cannot contain a 1 or 2 because this has to specifically be 1 or 2. 3 now. Where's the remaining 3 in box 9? Can't be here, can't be here. It must be here. So this is 3. This cannot be 9. The rest of this column, or sorry, this row is 4, 5, 7, 8. Nine. Still pretty broad. We know 8 has to be one of these 3 cells, so 8 cannot be any of these. But we still, it's kind of broad. The remaining cells in column 2 are 1, 2, 7, 8, 9. And this can't be 1 or 2 because of the 1, 2 pair here. This can't be 9. This can't be 8. The remaining cells in column 3 are 1, 2, 3, 4, 5. And this can't be 3, and this can't be 1 or 2 because of the 1, 2 pair. So 3 is one of these two. 9s. One of these is 9. We have a 4, 5 pair here. This can't be 9. The remaining digits in row 4 are 1, 2, 3, 7, 8, 9, but none of these can be 9. This can't be 9. This can't be 3. This can't be 3. One of these is 1 or 2. We're not sure which. This can't be 1 or 2. So the rest of this column, of this row, row 5, are 4, 5, 7, 8, and 9. Obviously, these can't be 9. This cannot be 9. We have a 4, 5, 7, 8 quadruplet in column 8, which eliminates 4, 5, 7, 8 in the rest of the column. This can't be 7 or 8. Therefore, this is 1 or 2. Again, this adds up to 33, which means this adds up to 12. Oh, what's the minimum this can be? 12. 1, 4, and 7. So therefore, this is the minimum. Because again, if it tried to increase anything, it would basically not add up to what the minimum would be, or what the actual value has to be, which is the minimum. So this is 1, this is 4, this is 7, which makes this a 2. That makes this 1, which makes that an 8. These can't be 7 or 8, so this is 9, which makes that an 8. This can't be 1, so this is 2. This can't be 4, so this is 5. These can no longer be 8 here. This can't be a 9. Therefore, the 7 has to be one of these two cells, which eliminates 7 from the rest of the cage, and this has to be a 9. Well, 8 can no longer be here, so 8 has to be one of these two cells, which means this can't be 8, and these can't be 8. This can't be a 1. This can't be 2, so this is 1, which makes that a 2, which makes that 1. So 1 cannot be in any of the in the cage. 8 is here. This has to be 1 out of 4, 5. It cannot be 4, so this must be a 5, which means these can't be 5. Therefore, it's a 4, 7 pair, which eliminates 4 and 7 in the rest of the row and the cage. So this can't be 4. This has to be 5. These can't be 4. It has to be 5 and 8, which eliminates 5 from the rest of the box it's in. So this is 5 and the row. So this can't be 5. This can't be 5. This is 5 and 3, which adds up with 1 to add up to 9. So this is 1. The remaining digits here are 8 and 9. And the remaining digits here are 4 and 7. Okay. 5 cannot be here. 3 cannot be here. Where is the 3 in this cage now? Can't be here. Can't be any of these. It has to be here. So this is 3. Remaining digits in row 6 have to be 2, 4, and 7. So this is 2, 4, 7. This is 2, 4, and 7. This can't be 5 or 8. We have a 4, 7, 4, 7 pair in column 8, which eliminates 4 and 7 in the rest of the column. So this can't be 4 or 7. It has to be 5 or 8. Let's see. Where is the 5 in this cage? Can't be here, can't be here, and can't be here anymore. So it must be here. So this is a 5, which means this cannot be a 5. We have a 4 set. This can't be 5, so this must be 4, which makes this a 5. Therefore, none of these can be 5. 4 can no longer be here or here, so this can't be 4. This is a 7. This can't be 4 or 7, so this is 2, which means this can't be 2. And this can't be 2, and this can't be 4. Therefore, where is a 2 in this cage? It has to be here. So this is 2. This is a 4 because of this 7. We have a 7, 8, 7, 8 pair in column 6, which eliminates 7 and 8 and from the rest of the column. So this is now a 9, which makes that an 8. Remaining digits here are 2 and 4. This can't be 2, so this is a 4, which makes this a 2. Therefore, this can't be a 2, and this can't be a 2. This can't be a 2 because of this 2, so this is a 1, which makes that a 2. Remaining digits in column 4 are 3, 5, and 9. And this can't be 3 or 9, so this is a 5, which means this can't be 5, and this can't be 5. Well, this can't be 5 here. Where's the 5 now in column 1? It has to be here. So this is a 5. Remaining digits here in column 5 are 1, 7, and 8. This can't be 1, so this is 7 or 8. This is 1, 7, or 8, and this cannot be 8 because of the 8 here, so this is 1 or 7 here. Okay. Where's the 9 remaining in this cage? It can only be here. So this is 9. We also have a 7, 8, 7, 8 pair in the cage, which eliminates 7 and 8 in the rest of the cage. So this can't be 7 or 8, so this must be 4, which makes that a 7, which makes that a 4. This can no longer be 4, so this is 5 or 7. If this were a 5, it would be less than this, and it can't be 5 anyways because this 5 here, so this is a 7, which makes this an 8, which makes this a 5. This 5 means this can't be 5, so it's an 8, which makes that a 5. This 7 means this is a 4, which makes that 7. This 7 means this is a 4. This can't be 4. And it cannot be 9 here. Well, where is the 9 possible in column 1 now? It has to be here. So this is 9, which means this can't be 9. This can't be 4. This can't be 7, so therefore this is 8, which makes that a 7, which makes that 8. This 7 also makes that an 8, which makes that a 7. This 7 and 8 means this can't be 7 or 8, so this is 1, which makes that 7, which makes that an 8. This 4 means this can't be 4, so this is 3, which means this can't be 3 or 4, so this is 1. This can't be 1 or 7, so this is 9, which makes that 3, which makes that 9. This can't be 8 or 9, so that makes that 7. This can't be 1, 7, or 8, so this must be 2, which makes that 1, which makes that 2, and that leaves a 4 here. And that's how you solve it. Pretty interesting. Yeah, pretty easy for me because I know a lot about killer cage sums, so it flows very well for me. I don't know if it flowed as well for you, but I hope you enjoyed the solve nonetheless. And I'll see you next time on Frank Puzzles. Take care.